Hi, today I'm going to be going over what you should do if you have a no start, no spark condition on your vehicle. In my case, it was a 1996 Dodge Grand Caravan 3.3 liter. Hopefully this can help you out in troubleshooting what's wrong with your car. I assume if you've clicked on this video, you already know you have a no spark condition. However, I'll just quickly go over what that means and how to determine if you actually have it. No spark means that your spark plugs are not firing. Unless all your spark plugs failed at the same time, it probably has something to do with the electrical system preceding your actual spark plugs. The easiest way to test this, of course, as you've probably done, is to unscrew a spark plug, put it into the wire, the little socket that you removed to take the spark plug out, and ground it, crank the engine, and see if the spark plug turns on or not. Chances are all your spark plugs probably aren't worn out, so we can move on to whatever is right before the spark plugs. Now, my engine is a distributorless system, which means I only have a coil pack right before the spark plugs. Now, before you go into testing your ignition coil pack using a multimeter and checking different resistances, see if they line up, it's easier to just unplug the actual connector that goes into the ignition coil and test if you have power there. It's very helpful to have a test light here since it allows you to easily verify whether or not you have power going through a connector. What you're going to do is plug in one end of the test light into the battery plus terminal and have the other end just go to ground. Any bare metal surface on your car will do, assuming that piece of metal is grounded. With that in place, what we're going to do is we're going to put the key into the ignition and turn it to just before you would crank. I'm going to refer to this as key on, and it's not the same thing as cranking the engine. Cranking is when you go one step further and you twist the key a little more, there's a little spring and you feel resistance and the starter motor starts turning. If you put the key on and you leave it there, what should happen is the light should flash on, and then it should turn off after like 1 second or so. If your light does turn on momentarily and then turns off, then you're good. If your light, however, does not turn on at all, that means that there's an issue with your ASD relay. That's the auto shutdown relay. The purpose of this system is to avoid unnecessary fires by turning off power to the injection systems, the ignition system, and overall just making sure that your engine shouldn't be running when the car is not on. The ASD relay will be located in your fuse box, and you can look at your fuse diagrams to figure out exactly where it is. There should be a couple of other relays, or the little cube looking things, that are exactly like it, and you can just take one out that looks unimportant based on the wiring diagram and put it in your ASD relay slot. And if you do the light test again and it works, that means the individual relay that you took out and replaced is bad. You could, of course, go to AutoZone or Rock Auto or somewhere online and buy a new relay, but generally it's kind of a waste of money because you can just test one of the other relays that you have in your car that belongs to like the windshield wipers or something rather inconsequential compared to the actual ignition system. Moving on, if your ASD relay is good, which means that your light turned on when you put the key on and then turned off, please note that in the following test you have to put the key on and wait for that ASD relay to flash before you begin cranking the car. If you don't do that, you won't be 100% sure that your crank is what's setting off the light or if it's the actual ASD relay going off. That's why every time you do it, you have to wait a couple seconds for that ASD relay to go off, and then you crank. Now what you're going to do is you're going to crank the engine. And there's one of two things that can happen here. If you crank the engine and the light flashes, that's going to be the first option. Or you crank the engine and the light does not flash. If you're getting a steady light when you crank the engine, that means that you are getting constant power to your ignition system. And your power issue lies between your connector and the spark plugs. So either the ignition coil is bad or your spark plug wires are bad. And these are both very easy things to test. They're pretty cheap parts regardless. The service manual covers all the specifications for testing these components. If your test light flashes momentarily when you crank the engine, that means that your crankshaft position sensor isn't getting a signal to the PCM. This can either be an issue with the wires coming out of the sensor or the sensor itself, and we'll cover how to test all this later on in the video. If, however, like me, you are not getting a steady light on when you crank the engine, that means that you are not getting power to your ignition system when you're cranking. And this test is very helpful right now because we know for a fact that the wiring between the PCM and the ignition coils is good, because in our first test, our light turned on. However, it's only when we crank it that we don't get power to that. The next part of the test involves unplugging the crankshaft position sensor, and that's located on the bottom right part of the engine. It's a little tough to get to, but you don't actually have to unplug the sensor from the engine. You just have to unplug the connector that goes from the sensor to the rest of the wiring. If we crank the engine again, we should have one of two results now. Either we're going to have a flash or we're not, and both of these tell us quite a bit. If your light did flash, that means that your crankshaft position sensor, the one you just unplugged, has a short in it, and you just need to replace that part. Or if you replace the part and it still doesn't work and you still repeat the procedure and you get the same issue, there's a short in the wiring after the connector to the sensor. The other option is, of course, that you didn't get a flash at all. And this is the toughest of the options, and of course it's the one I got. And what this basically means is that there's an issue with the wiring of either the crankshaft position sensor or the camshaft position sensor. Of course, this could also mean that the sensors are just bad, but that should be a pretty straightforward fix. You just swap the part in and replace it. The tough part now becomes figuring out what part of the wiring is bad, or are the sensors bad? Both of these sensors have 3 wires that come out of the sensor, and the setup is exactly the same. One of them is an 8-volt power supply to the sensor, one of them is a signal ground, and one of them is the actual signal itself. Please double check with your wiring diagrams. However, on mine, on the 3.3 liter engine, your 8-volt power supply is on the rightmost pin if your latch is on top. The sensor ground is in the middle, and your sensor signal wire is the leftmost one. Just to confirm, your 8-volt power supply will be a orange wire, your ground will be a black wire, and your sensor signal should be a yellow wire. So what are we going to do now? Basically, all we're going to do is unplug the sensor cables and check for continuity and what resistance we have between the sensor connector and the PCM connector. Now, if we look at our wiring diagram, we can see that we have circuits K7 18OR orange, circuit K4 18 black, K44 tan yellow. So we're just going to find these and see where they end up on the PCM pinouts. Now we're just going to look at our PCM pinouts and identify which circuits correspond to what pin. Now the camshaft and crankshaft sensors are pretty easy to find. You're going to have 2 connectors, C1 and C2. And all that you're going to find on C2 that you want is pins 43 and 44, which correspond to the same circuits for our sensor ground and our 8-volt supply. And on our module for C1 on our engines, you have to make sure that you're on the right engine. we're going to use our crankshaft position sensor signal at pin 32 and our camshaft position sensor at pin 33. So now all you're going to do is take one of your multimeter leads, put it into one of the pins on the sensor circuit connector, and you're going to put the other lead to the corresponding pin in the PCM. Just don't shove them in there because these pins are quite delicate. You don't want to warp the inside of the connectors. So now all we're going to do is put our multimeter on continuity or a diode test. That's the one where if you touch the two probes together or if you touch the two ends to a continuous piece of wire, it'll beep. Now all you have to do is, for example, if you want to check the sensor signal for the camshaft position sensor, put one of your leads on the sensor signal connector, and then put the other one on the pin corresponding to the camshaft position sensor signal, which would be pin 33. And you're going to repeat this for both connectors, and make sure that all the wires have continuity and fairly low resistance, preferably below 1 ohm. If you don't have continuity at all, you can try sticking a needle in the wire, a very small needle, behind the connector itself to make sure that the wire is not broken. Otherwise, you know that your actual connector is wonky and that the connection between the connector and the wire itself is bad. So what do you do if one of your connections is bad? Well, you have to track down that wire and find where it's broken. And if you can't do that, you're going to need to somehow splice the wire from the PCM to the actual sensor itself. That's kind of a tough job in and of itself, but I don't see any other way of doing it short of taking apart the entire wiring harness and finding exactly where that is, although that is the cleanest case. That is the best end result. And the alternative, of course, is what happened to me, where I test all these wires, check them all for continuity, and they're good. All the wires are good. So what's the deal right now? Now we have to test whether or not our sensors are outputting the proper values that they should, and whether or not they're working correctly when we actually crank and start the engine. To do this, you're going to have to stick some kind of needle or a little splice behind the actual connector for the sensors, and run a wire so you can test it easily with your multimeter as the car is running. I'll draw a little picture right here so you can see roughly what this looks like. But now essentially we're testing these sensors when they're live. The easiest thing to test will be your 8-volt ground. What you're going to do is touch the probe to your 8-volt wire when the sensor is live, and touch the other end of the probe to ground, and when your key is on, you should have 8 volts. In my case, I had 8.93 or something like that. Generally around 8 volts will be fine. You can test this for both the camshaft and the crankshaft position sensors. It's fairly straightforward. Next, you're going to test the same 8-volt circuits when you crank the engine. And ideally what should happen is you crank the engine and you maintain a constant 8 volts. So you know that power isn't getting sucked off somewhere else and that you have a constant supply of power to these sensors. After we've done that, we're going to test our signal wires. Now when your key is on, you want your signal wires to be very low, as close to 0 as possible, and if you're new to using a multimeter, just make sure you're in the correct scale, because it can very quickly go from looking like 6 volts to actually being 6 millivolts. In my case, I had something like 4 to 5 millivolts on my sensor signal wire when I probed it to ground. It seems to me that's acceptable. I can't find any specification from the manufacturer on that. So just keep your key on sensor signal as low as you can. The tricky part, of course, now will be testing the sensor signal wires when the car is being cranked. Most multimeters won't be able to resolve the signal quickly enough to actually get you a real reading. The actual signal that is going from that sensor alternates between half a volt, so 0.5 volts, and 5 volts. Because the camshaft and crankshaft position sensors are detecting little notches in a flywheel that are, I don't know, maybe ½ inch apart, and the flywheel rotates at 300 to 400 rotations per minute, the time between a ½ volt signal and a 5 volt signal will be a couple of milliseconds. It's extremely quick. If you had an oscilloscope, it would be very easy to actually see what those values are because you have a voltage versus time graph, and you can just look back, change the scale, and examine what your peak voltage times are. However, in my case, I don't have $300 to $400 to spend on a scope, so I'm stuck with my multimeter, which updates, I don't know, maybe 5 times a second. When you're reading your crank values for your signal wire, I've found that an acceptable value will be 3.5 volts. Now, obviously, your value will fluctuate. You'll see a bunch of zeros, you'll see a bunch of maybe sixes. Generally, because the multimeter averages by taking a root mean square, you'll see around 3.5 volts. Since you have no way of actually resolving whether or not you are getting 0.5 volts, then 5 volts, unless you have an oscilloscope, it is very, very important that you stick to this 3.5 volt rule. Make sure that both your camshaft and your crankshaft position sensor signal wires are reading the same value on your multimeter when you're cranking your car. In my case, I had the proper 3.5 volts on my crankshaft position sensor. However, on my camshaft position sensor, I had 2.5 volts. And at first, since I was doing this for the first time, and I didn't really have that great of a multimeter, I figured, hey, 2.5 volts is good enough. As long as it's reading something, it's probably good enough. I was very wrong. It has to be 3.5 volts, or one of the sensors has to match the other. In your case, your multimeter might take a different reading, but please make sure that if you have a discrepancy between one sensor and the other, it's probably one of your sensors. In my case, it ended up being the 2.5 volt reading sensor, which was my camshaft position sensor. Moving forward, I didn't really expect that either of the sensors were bad. I figured, hey, 2.5 volts, 3.5 volts, good enough. Both of my sensors are okay. I've confirmed that my wiring is okay from the sensors to the PCM. And I've confirmed that the wiring from the PCM to the ignition coils is fine. So what are my next steps? The only logical conclusion I can make here, since my ASD relay is good, is that my PCM is bad. I ended up purchasing an identical PCM for my vehicle, same exact engine, same features, and this is important, but the year doesn't really matter. If these Dodge Grand Caravans, I believe, range from 1996 to 2000, so the years are generally the same, but you have to make sure that if your car didn't come with an alarm, initially, a security system, that the computer that you're buying also did not have an alarm, because that could lock up another computer inside your car called the body control module, and you don't want that to happen. It's a pretty expensive part. So just order your ECM online from someone, or your PCM online from someone. They'll flash your VIN on, everything will work fine. Usually what happens is you buy it online, they ship you theirs. There's a shipping label in the box, you send it back. It's called a core change, and you're good to go. Sometimes it's a little easier to just buy the ones where there's no core change. That's just my recommendation. When I had my new PCM, I verified that the computer was good, since what are the odds that two separate computers, have the same exact little problem where one of the sensors is not getting picked up by the PCM? I mean, the odds of that are like infinitesimally small when it comes to thousands and thousands of components in one of these computers. So the only thing I had left at this point was my voltage discrepancy between my camshaft position sensor and my crankshaft position sensor, because to summarize, my wiring is all good from the sensor to the PCM. Now I know my PCM is good. The ASD relay is good. The wiring from the ASD relay to the ignition coils is good. So what's the deal here? The only thing I have left is my 2.5 volt versus 3.5 volt sensor difference. So I go in and check my camshaft position sensor, because that's the one that's reading lower than what I read was the nominal voltage. And I mean, the sensor looks fine. It looks completely fine. But what ended up happening is my dad and I replaced this part maybe, I don't know, 3 or 4 times. And it ran fine. But this last time when things didn't work at all, what happened is the sensor spacing was off. And when we reinstalled it properly, we realized that you have to twist it a little and push very hard on ours to get the sensor to fall just very slightly deeper than it would if you would put it in normally. And the little paper that comes on your sensors, that's the right thickness, that's the right spacer for the gap. And you have to make sure that your gap is anywhere from 1 to 1.5 millimeters from the actual flywheel. That's what the paper spacer is for. It's very important that you maintain that distance. And in our case, since the sensor didn't go in all the way, it was reading a very slightly lower voltage, and the PCM wasn't picking up the crankshaft position sensor signal, or the camshaft, sorry. When we actually put it in properly, car started up fine. So we spent 3 days and nights trying to diagnose what the problem was, running a wire traces across all these different components, confirming everything works, just to find out that we didn't put it in properly. One little stupid rookie mistake, we didn't put it in properly, and the whole engine wouldn't start. So over one tiny little thing, we had until we finished it on Saturday afternoon. We had until Monday to move our car for street cleaning, and this car was like a total piece of junk. We were ready to call the tow truck to take it to the junkyard and scrap this thing. We were literally, I don't know. I think if we didn't get it at that point, we would have called the tow truck and just we would have gotten it just junked, just completely scrapped. It's one tiny little mistake. Thanks for watching. I hope you learned something from this video that might help you fix your car.